Okay, let's unpack the keynote in a way that feels like a live-action panel we can actually read through. Jensen Huang just announced that Nvidia is on track to rewrite the foundations of every digital infrastructure layer ***, from cloud data centers to edge robots, by embedding AI at the core of where all our data lives. The idea is that GPUs are not only the fastest chips for graphics anymore, they're now the only * platform that can do accelerated graphics, HPC training, inference, and even autonomous physics simulation on a single stack.
That's what makes the conversation about monopoly and centralization so intense. Nvidia's GPUs already run every major AI workload, from large language models to robotics control loops. And because they're selling the entire ecosystem, hardware, software libraries, cloud-style services, one company is effectively becoming the gatekeeper for all digital data and every enterprise's ability to create or consume tokens * in an AI economy.
Exactly, but let's keep it * structured so we can see where each piece lands. We'll go through three main sections: accelerated computing and GPU dominance, AI as essential infrastructure and token economy, and physical AI and simulation-first development. For each, we'll point out the good aspects: speed, standardization, democratization, and the bad barriers to entry, vendor lock-in, antitrust concerns. Section 1, accelerated computing and GPU dominance.
Jensen's opening highlighted how Nvidia invented CUDA 30 years ago, and how that rendering code evolved into a platform for * accelerated computing across every industry. GPUs now run SQL queries, Spark jobs, EDA simulations, CAE analyses, and even national security workloads at the speed of light. That's the good: unprecedented simulation speed, faster product development, and massive cost savings in research.
The downside is a high barrier for smaller firms or new entrants that can't afford the GPU hardware. Accelerated computing has turned into a * capability lock *. If you don't have Nvidia GPUs, you're stuck behind a wall of code that only runs on their architecture. And when you're locked into CUDA libraries and proprietary APIs, moving to another vendor is not just a matter of swapping chips, it's a wholesale rewrite of your software stack.
And because the GPU ecosystem has become so tightly coupled with Nvidia's hardware roadmap, 3 teams for 2 seasons historically, now 9 teams for 4 seasons, the company can outpace competitors in terms of feature refreshes. That relentless pace creates * network effects. Once you're on Nvidia's platform, every new generation of software can be optimized to run faster and cheaper on their next GPU family, e.g. H100, L40. The cost of switching is high enough that many firms stay put.
Let's note the positive * impact. Engineers can simulate complex physics at a fraction of the time it used to take months. Accelerated computing also fuels AI itself. Training large language models now relies on GPU-based tensor maths, which would be impractical on CPUs alone. The negative * is that all this power is in one place, creating a single point of failure for critical national infrastructure.
We're already seeing this in practice. Jensen said the GPU is the only GPU that can do image processing, computer graphics, SQL, Spark, data processing at speed of light for governments and enterprises. That means when your company needs to process petabytes of data or train a new model overnight, you're * forced to use Nvidia GPUs because they deliver the performance required. If someone else built comparable performance, it would require an entire re-engineering of the software stack.
And that's why the transcript highlighted their partnership with major cloud players, Dell Technologies, Microsoft, Google, to offer GPU-based services at scale. The good is that you can now spin up a data center or edge node on Nvidia hardware quickly and reliably. The bad * is that it also gives Nvidia a lever to set pricing, control access, and potentially decide which workloads get priority. Section 2, AI as essential infrastructure and token economy.
In the panel Accelerated Computing, Jensen said AI is rewriting industry rules, redefining security, accelerating science, retooling manufacturing. He also talked about a future where every enterprise either produces tokens or consumes their *. That means companies that don't generate AI outputs will be judged solely on how efficiently they consume tokens from the world.
Right, the transcript's panelists Mark Aki talked about data as code and token consumption. If Nvidia controls the compute hardware that produces those tokens' AI inferences, it can decide who gets to run workloads and at what cost. That centralization is a double-edged sword. On one hand, you get a unified high-performance platform. On the other, you risk * locking out competitors and creating a single supplier of AI infrastructure.
Let's dive into the good *. AI as essential infrastructure means that advanced analytics, autonomous systems, and intelligent automation become part of everyday business operations. The transcript mentioned that accelerated computing is already transforming manufacturing, healthcare, robotics, and more. By making GPUs part of the core platform, Nvidia lowers the barrier for small to medium enterprises, SMEs, to adopt AI-driven workflows.
And the bad asterisk side, a monopoly on GPU compute could allow Nvidia to set prices that effectively become the asterisk cost of doing business for any company relying on AI. If all token producers, think LLMs, vision models, robotics controllers, are running on Nvidia hardware, then pricing and availability become strategic levers. Regulators will scrutinize this because it resembles a digital infrastructure monopoly akin to telecom or energy.
Another angle is the asterisk token producer-consumer dynamic that Jensen emphasized. Enterprises that can't produce tokens, AI models, will be entirely dependent on how efficiently they consume tokens from Nvidia-based services. If you're locked into their ecosystem, your business success becomes tied to Nvidia's pricing and policy decisions.
The transcript also highlighted the open model ecosystem, Aravan, Mistral, Black Forest Labs, all leveraging Nvidia GPUs for inference. That good is that open models lower costs and enable rapid experimentation, yet the GPU remains the bottleneck. Even if you fine-tune a small open model on an edge device, the underlying compute still needs to be fast enough to meet real-time constraints, something only high-end Nvidia GPUs can deliver. Section 3, Physical AI and Simulation First Approach.
Let's switch gears. The panelists from Wabi, self-driving trucks and robot taxis, PhysicsX, Skilled AI, and Open Evidence talked about building simulation-first platforms that rely on Nvidia GPUs to train physics-based neural networks faster than traditional solvers. That's a good. You can now run millions of jet engine or autonomous vehicle simulations per day, something that would take humans months with classical numerical methods.
But the bad asterisk is that these breakthroughs are still tied to Nvidia hardware. Physics engines, physics-based simulation, and real-time inference for robotics all require massive compute. If only Nvidia GPUs can provide the throughput needed, they're not just a vendor, they're the sole provider of simulation infrastructure.
Jensen's keynote was clear that AI will become essential infrastructure just like electricity or the internet in earlier eras. That centralization means every data center, edge node, and even personal laptop could be built around Nvidia GPUs. The good asterisk is standardized performance, easier software portability, and a coherent security model across the stack.
The bad asterisk is that this concentration of compute creates a new kind of asterisk digital choke point. If your data, models, and analytics all funnel through Nvidia's cloud or on-prem solutions, you're potentially exposing sensitive data to a single vendor. That raises privacy, sovereignty, and regulatory concerns, especially as governments look at AI infrastructure in the same light they looked at the power grid.
Another concern is that Nvidia could wield asterisk pricing power over critical national infrastructure if all AI workloads run on their GPUs. Think about autonomous vehicles, industrial robots, or even military systems that rely on AI for decision-making. If the only way to get the compute needed is through Nvidia hardware, you're effectively tied to them.
And let's not forget geopolitical friction. Nvidia is a US company with global reach. If a country wants to build its own data centers or autonomous vehicles but can't find affordable high-performance GPUs outside Nvidia's ecosystem, it might be forced into an allied supply chain. That has implications for national security and technology sovereignty. Section 4, the token economy and AI-powered digital twins.
Jensen mentioned that enterprises will either become token producers or consumers. In practice, this means any business that wants to run large language models or vision systems will need GPU compute, most of which comes from Nvidia. That good point is that the platform model can be sold as a service, making high-performance AI available on demand.
The bad asterisk side is that if Nvidia controls the tokens, they can influence data flows and potentially set usage limits or price tiers that dictate who gets to run large models and when. This could lead to an uneven playing field where only big players with deep pockets can afford continuous inference at scale.
And as the transcript mentioned, AI infrastructure is becoming foundational asterisk. You'll see the same 5-layer cake Jensen described for AI factories: compute, memory, storage, network, power. If one company controls all those layers, they're effectively controlling the entire digital economy's backbone. That centralization can foster rapid innovation, but also invites antitrust scrutiny and calls for open standards. Section 5, Open Models versus Proprietary Ecosystem.
The panelists on open models, Perplexity, Mistral, Black Forest Labs, highlighted how open weight models lower cost and speed up experimentation. That's a major asterisk, good asterisk. Developers can fine-tune models locally, run inference on premises, and avoid vendor lock-in.
Yet Nvidia is still investing heavily in proprietary models like NeXT or the upcoming Neuro family of weights that showcase GPU performance at scale. The bad asterisk is that even if open models exist, you still need high-performance GPUs to train them efficiently. So open weights don't automatically break the monopoly, just reduce cost for end users.
Also, Jensen's statement that AI will become essential infrastructure means companies may start buying Nvidia's cloud-based inference services as a core part of their operations. Even if you bring your own model, you'll still need to run it on an Nvidia GPU to hit the performance targets, so proprietary models keep giving Nvidia leverage. Section 6, Physical AI and Safety.
The physical AI panelists, Wabi's autonomous trucks, PhysicsX's simulation stack, Skilled AI's general brain for robots, all use Nvidia GPUs for training physics-based neural networks that can simulate jet engine combustion or robot navigation at orders of magnitude faster speed than traditional solvers. That good means design cycles shrink from months to days.
The bad asterisk is that safety-critical autonomous systems rely on simulation and inference performed on Nvidia hardware. If only Nvidia GPUs can deliver the required throughput, then safety validation, data collection, and real-time decision-making all become tied to a single vendor's platform. That raises concerns about reliability, security, and regulatory compliance.
And the transcript emphasized that simulation first asterisk is the path to verifiable safety in autonomous vehicles and robotics, something that would be impossible with slower, traditional numerical solvers. The downside remains that you still need Nvidia GPUs for both simulation and inference. Section 7, Global Digital Infrastructure and Geopolitical Impact.
Jensen's analogy that AI infrastructure is the transformative driving force of the next wave mirrors how electricity powered the industrial age and the internet powered the digital age. If Nvidia becomes the core of every data center, edge device, and even personal computer, we're looking at a new centralized power base.
That centralization has good outcomes, standardized performance across global deployments, predictable software portability, unified security models, and lower costs for end users through cloud services. But the bad asterisk is that it gives Nvidia a lever to control data flow, pricing, access to AI compute, and potentially even influence on national security decisions.
We'll see regulatory bodies examining whether Nvidia's hardware-based dominance constitutes a monopoly over critical digital infrastructure, similar to how antitrust cases were filed against telecom or energy giants. There are also concerns about data sovereignty if all AI workloads funnel through Nvidia's cloud, and privacy if sensitive data is processed on their GPUs. Closing thoughts.
Summarizing the big takeaways from Jensen's keynote and the transcript. 1. Nvidia's GPU stack now powers everything from HPC to autonomous vehicles, making it a single point of failure for digital infrastructure. 2. AI, as essential infrastructure means that all enterprises will need to consume tokens, which places Nvidia in control of compute pricing and data flow. 3. Open models lower barriers for developers, but still rely on Nvidia GPUs for training and inference performance. 4. Physical AI, robotics, autonomous vehicles, is accelerated by simulation-first approaches that depend on GPU compute, again tying these new industries to Nvidia's hardware.
The good side is rapid innovation, democratized access through cloud services, and the promise of safer, faster design cycles across engineering and physical AI. The bad side is concentration of power, potential vendor lock-in for smaller firms, antitrust scrutiny, and geopolitical risk when national infrastructure becomes GPU dependent.
Jensen's message was clear: AI will become essential infrastructure. That's a paradigm shift comparable to electricity or the internet. But it also means that one company could dictate how data is processed, who can run AI models, and how quickly new technologies roll out worldwide. The balance between opportunity and competition will be the defining debate of this era.